All right, before I start our review key, I just want to remind you that on the test, you will not be able to use your notes or a calculator. So we're going to do this review without a calculator. I would suggest if you're doing any of the problems to try them without a calculator because when you get to the test, you won't be able to use one. The numbers are simple enough on the test. They are just like the ones that you'll see here that you won't need a calculator. And just think, if you get stuck on a number, break it down into its prime factors, right? Do the little tree, and that will help you. All right, so let's start with our first one. Square root of 16 divided by the square root of 36. So the square root of 16 divided by the square root of 36 can also be written like this. And so remember, we already know these square roots, right? The square root of 16 is 4 and the square root of 36 is 6. This is not your simplified answer because we can reduce our fraction here, right? So this is going to be 2/3. That's going to be your final answer, all right? Here we go. This is negative 25 to the 3/2 power. Now I want you to notice that negative is not included with the 25 because it's not in parentheses. This is different than this, right? That's not what they're saying here. They're saying just the 25. So whatever it is, we're going to leave it on the outside. This 2 becomes our root or our index. So it's the square root of 25 to the 3rd power. We can do one of two things. First, we can take the square root first and then raise it to the 3rd power. Let's do this because then it'll leave us with smaller numbers. So square root of 25 is 5. 5 cubed is 125. And that's your final answer. Now, we forgot the negative, right? Whatever comes out of there is a negative. That's what it means when it's on the outside, that negative stays there no matter what. All right, so our 243 to the negative 2/5 power, if you have a negative exponent, that means we need to put it in the denominator to make it positive. So we have 243 to the 2/5 power. We're going to write this as a radical. So we have the 5th root of 243 squared. Now this is one of those occurrences where it's like, I don't know what the 5th root of 243 is, but I can break it down into my prime numbers. I do know that 3 goes into 243 81 times. That's convenient, right? This is 9 times 9 and 3 times 3. So I'm looking at my prime numbers and I'm going to find a group of 5. I found one group of 5. So I'm going to take one of those numbers out. So I can take the 1 out. It doesn't go to the numerator yet. And now don't forget that square, we still have to square it on the end. So we have 1/9 is our answer. All right, next one, number 4, we have 16 to the 3/4 power. I'm going to bring this 4 over here. So we have the 4th root of 16 to the 3rd power, right? The denominator is your root and your numerator is your exponent. So let's break this down. 4 and 4, 2 and 2. I'm looking for a group of 4. I see a group of 4, 2 it is, and then I'm going to raise it to the 3rd power. That means 2 times 2 times 2, which is 8. So that's your answer for that one. All right, number 5. This one's a little bit tricky. It's the cubed root of 0.001. And I want to know, what can I multiply 3 times to get 0.001? So I want to know, what is this number? And you could probably already think about it, right? Oh, come on, focus. Without using a calculator. So remember when you multiply numbers that are behind decimals like this, like if I say 0.5 times 0.5, this is 25, and then see, I have 2 numbers behind the decimal, so it's 2 numbers behind the decimal here, so it's 0.25. So if I'm multiplying 3 numbers and I have 3 numbers behind the decimal, I know each of these numbers is just going to be 1 number behind the decimal. Well, what times what equals 1? It's 1, right? So your answer there is 0.1. Now we can test our theory here. 0.1 times 0.1 times 0.1. Well, 0.1 times 0.1 is 1. And then there's two numbers behind the decimal, so it's 0.01. And then I have 0.01 times that last 0.1. 1 times 1 is 1. And I have three numbers behind the decimal. So that gets us our 0.001. You do have a question like this on the test. And I think it is 1, but just to let you know. All right, next one, 81 divided by 16 to the 1/4 power. Let's go ahead and distribute both of these. I can't reduce 81 and 16, so I'm just gonna say, all right, this is 81 to the 1/4 power, and this is 16 to the 1/4 power. Now let's move these and make them a radical. So it's the 4th root of 81 divided by the 4th root of 16. Hopefully you know this by heart, but if not, we can break it apart. This is 9 and 9. 3 and 3, 3 and 3. I'm looking for a group of 4. I have a group of 4 here. It's 3. Let's do the 16, 4 and 4, 2 and 2. I'm just doing it out to the side because I didn't have any room underneath. It's a 2, so your answer there is 3/2. All right. Next one, this is kind of the same thing as number 2, where this negative isn't a part of our radical here. So whatever our answer is going to be negative, okay? 4th root of 81, hey, I already know that from the last question, it's 3, so my answer is 3, negative 3, sorry. All right, negative exponent, in order to make our exponent positive, we got to put it in the denominator, the whole thing. So I'm going to move this to a radical. So we have 1 divided by the cubed root of 27 squared. So let's find the cubed root first, and then we'll square that number. Not 2, how about 3? Notice that a lot of these are just using 2s and 3s, very small numbers, so you don't need a calculator to do that. That's going to be like the test too, smaller numbers, just breaking them apart. So the cubed root of 27 is 3, so I have 1 divided by 3 squared, and it's going to be 1 to the 9th, 1 divided by 9. So notice that the exponent was negative, not the number. So the number is not negative. It's just, it means that it's in the denominator. All right, we have the 6th root of negative 64. Now look at the difference here. You have the negative 4th root of 81, the 6th root of negative 64. That means I multiplied a negative number 6 times, 1, 2, 3, 6 times, right? And got a 1, 2, 3, 4, 5, 6, and got a negative 64. Now think, is that possible? Can I multiply a negative number an even amount of times and get a negative number? No, you can't. So we're going to call this imaginary. If you just write imaginary for your answer, that's totally fine. But let's see if it does break apart. 8, 8. This is 4 and 2, 2 and 2, 4 and 2. I'm running out of room here with all that multiplying that I did. So it is 2. So that means that it is going to be 2i, right? It happens with our imaginary numbers there. I mean, with our negatives of even roots. Let me get my words right. All right, next one. This one's pretty much like number 5 that we did earlier. So I want to know what multiplies 3 times to get 27. So I can break apart 27, 9 and 3, 3 and 3. And I know that it's 3, but how many is it behind the decimal? So I have 1, 2, 3, 4, 5, 6 behind the decimal. That means I multiplied a number 3 times to get this, this decimal. So I want to know how many numbers is it behind the decimal? Well, it's 6, right? So I'm going to say it's 2 because every time you have to add the decimals together. So let's test our theory here. 0.03 times 0.03. 3 times 3 is 9. And I have 1, 2, 3, 4 numbers behind the decimal. And now I have that 0.009 times another 0.03. And so that's 27. And I have 1, 2, 3, 4, 5 behind the decimal. Is that right? 1, 2. Oh, I missed a 0, didn't I? 6. I was like, wait a minute. 1, 2, 3, 4, 5, 6. There we go. All right, so that matches. So our answer is 0.03. So if you can come up with a pattern there, that might help. Like thinking about how many it is. If it's 6 zeros, then divide that by 3. That means that each one would have 2 zeros. Same thing as we did up here. If it has 3 zeros, divide that by 3, that cubed root, and you have one decimal behind, one number behind the decimal for each one. All right, next page. This one's a kind of interesting number 11. We can think about it like this. We just want to write it in exponential form as our directions up here. Do not leave any negative exponents in the final answer. So we have the 5th root. Now look, both of them are written separately. This one's written in radical form. This one's written in exponential form. Let's go ahead and write both of them in exponential form. That way we can work with them a little bit better. So this is to the 1/5 power. And this is to the 4/5 power. Now, I know that when we have, when we're dividing, we can subtract our exponents when our bases are the same. So our bases are the same. We can subtract that 1/5 minus 4/5, and we get negative 3/5. So if my exponent is negative, I know that it needs to go to the denominator to make it positive. Now, for these, I'm skipping a step, hang on. So this is positive 3/5. Now it says written in exponential form. So I'm going to leave it like this. Okay. So when you get to this part, you want to write it in exponential form and you want to make sure that they're positive. Okay. So we're going to leave it like this. All right. Next one over here. This one's a little bit tricky. If you're raising a power to a power, let's distribute that power first. So we have goes to every single thing, even the ones in the denominator, right? So it goes to the 4. So this is 4 squared. This is x to the 1/2 squared. This is y to the negative 1/3 squared divided by 5 squared. And this is just an extra step, just so you can see x to the 1/3 squared, y to the 5/6 squared, and z squared. All right, so when we raise a power to a power, we're multiplying. In the numbers, we don't do 4 times 2, we do 4 times 4, right? Because it's 4 squared. So don't forget, if you're raising a number to a power, you're actually, that's the exponent. You have to do that. So it's 16. Let's think about what's on top and what's on bottom. This is 25, right? I'm going to do it piece by piece. X to the 1/2 times 2, half of 2 is just 1, right? And then negative 1/3 times 2 is y to the negative 2/3, right? Negative 2/3. 5 squared is 25. We already did that. 1/3 squared is x to the 2/3. And then multiplying these, 5/6 times 2 is 10/6. And then z squared. All right. So next step, I noticed that I have a negative exponent. So let's move that negative exponent down to the denominator to make it positive. And then we can simplify. So we have x to the 2/3, y to the 10/6, y to the 2/3, and z squared.
Staff will be conducting our hazmat drill in a few minutes. When the drill commences, please go review slides 12 and 13 of the campus safety operations.
All right, sorry, we're doing a hazmat drill. All right, now what do I notice? I notice that I have same bases here, so I'm going to subtract. So this is 1, right? And then when I have same bases here, I'm going to add because I'm multiplying. So when you divide, you subtract. When you add, when you multiply, you add. So we're going to do it 1 minus 2/3. I'm running out of space. Copy it on here. All right, so we have x to the 1, and I'm going to write that as 3/3, right? Just to write it as a 1. 25x to the 2/3, y to the 10/6, y to the 2/3, and z squared. All right, so 3/3 minus 2/3, that's 1/3. So if it's positive, it goes in the numerator, right? So x to the 1/3 power, right? And then down on the bottom, we have 25, and I'm going to add 10/6 plus 2/3, right? Well, 10/6 plus 2/3, I need a common denominator, so that's the same as 4/6. So I have 10 plus 4 is 14/6. Let's go ahead and leave it like that. We don't want to get too ugly here. And then we have z squared. Now, because it says in my directions, I want to leave it in exponential form, we're going to leave our answer like that, okay? I know it's not pretty, but that's what my directions say. So I'm going to leave the answer like that. 25y to the 14/6 z squared. And we can leave that as a improper fraction for the y value. Yeah, that one's just, ugh, I didn't like doing that one. It's okay, sometimes we have questions we don't really like. All right, next one here. Notice that my bases are the same. So before I distribute that, the exponent here to each of the terms, I can know that if I'm multiplying, right, what can I do with my exponents? I can add the 1/4 and the 7/4, which gets me 8/4 or 2. So this is the same as 5xy squared squared. Now we can distribute that to each of the numbers here. So we have 5 squared is 25, x squared is x squared, y squared raised to the second power is y to the 4th. So before you do anything,
Attention, please.
see if it's,
There is a potentially dangerous situation outside our facility requiring us to shelter in place. Immediate
I feel like every time I make a video, something happens. All right, so before you do any distribution of the exponents, just see if your terms are the same, okay? And in this case, they are, and you can add the
Attention, please.
exponents.
There is a potentially dangerous situation outside our facility requiring us to shelter in place. Immediately move to your designated safe zone.
All right, so our next one here, notice that my indices are the same, the 4th root. So what can we do when we're multiplying? We can go ahead and multiply these together. So this is the 4th root of x squared times x to the 14th, right? So we can rewrite this as the 4th root of x to the 16th. Now let's see if we can break this apart. Now I'm going to write them all out, even though this is like the slowest way that we could do this, right? Or the most time consuming. And I'm going to look for 4 groups. But I want you to notice too, that this is x to the 4th, that I can also divide 16 divided by 4, because this can also be written as x to the 16th over 4. And if we just divide that, we would get the same number, right? So think you can, if it's a big number here as my exponent, you can just divide your exponent and your index and still get the same answer, okay? But x to the 4th, but writing it all out is perfectly okay. Sometimes I need to see it too. X to the 4th would be your answer there. All right, same thing here. They're both 5th root. So I can say the 5th root of a squared times a. Now this is a to the 1. So our answer is the 5th root of a cubed. Notice that there's not a group of 5a's. So this is just your answer. Ooh, exponential form, right? We should have written it in exponential form. So it should be a to the 3/5 power right there. All right, next one here. I want you to notice this. This has a negative exponent. That's gross. We don't want that. We want to put it in the denominator to make it positive, right? So here we go, x to the 2/5. Now, because I'm adding here, we can't really do anything. So we're just going to leave it like this. And this is going to be our answer because we had to put it in exponential form, right? And we're okay with that. All right, next one. Okay, couple of different things happening, being raised power to a power. So we're going to go just like we were distributing inside up here. We're going to do the same thing, except we're going to start from the back one. We're going to distribute inside. So this is 3x squared y to the -4th to the 4th power. And now we'll distribute it inside like this. So we have 3 to the 4th power, x squared to the 4th power, and y to the -4th to the 4th power. So we have 3 to the 4th. That's 3 times 3 times 3 times 3. That's 9 times 9. We get 81. See, you don't need a calculator, right? 81. Multiply our exponents, x to the 8th. Multiply our exponents, y to the negative 16th. Now, I have a negative exponent. I need to put it in the denominator. Goes down here, and that's your answer. All right, next one. Notice that your negative is out here. That means your answer is going to be negative. Whatever you're getting, you're staying negative, okay? All right, two things you can do here. You can distribute the -2, and that's totally fine. Actually, let's go ahead and do that. So -2 to all of these things. So we have 5 to the -2 power, x to the 3rd times -2, and you can skip this step, but it helps to see it sometimes. And then that negative stays out there. So how do we do that? I don't even know how to do that yet. Let's leave it. Multiply here, x to the -6th and y to the -4th. Okay, how do I do this? I can't do it because it's a negative exponent, so I need to move it to the bottom. So anything that has a negative exponent moves to the bottom. Anything that has a negative exponent on the bottom moves to the top. So we have on the top y to the 4th, and on the bottom we have 5 squared, which is 25, and x to the 6th. You guys already knew that. All right, next question, number 19. We have a to the 4th, and then we have the cubed root of a squared y cubed. All right, so I need, because my directions are saying exponential form, we have to make sure that it's exponential form. My first inclination is to look for groups of 3. However, that's not what they want us to do. So I want to move this to an exponent or exponential form first. So this is a to the 4th times a to the 2/3 times y to the 3/3. Now let's see what we can do. These have same bases, so I can add the exponent. So I'm going to do 4 plus 2/3. Well, this is 4 over 1. I need a common denominator, so that's 12/3 plus 2/3. That's 14/3. So I have a to the 14/3. That's kind of gross. And then I have y to the 3/3. 3 divided by 3 is 1, right? So it's just y to the 1. So that's your answer. Now, if it said do it in simplest radical form, then you would look for the groups of 3. But because it's asking you to do the exponential form, that's when you move it. All right, last page. This one was on our bingo card. So let's see, we have 25. Now we are simplifying, and it should be in radical form, okay? So we have 25 times 2, 5 and 5, and we have 4 x's. So I'm looking for groups of 2. If there's not a number here, that means you're looking for a 2 because it's squared. So I have a 5. I have 2 groups of x's, and I have a 2 that doesn't have a pair, he stays inside. That's your answer. All right, next one, I'm looking for groups of 3. So I'm going to do 12 times 4. You can do any number, it will all come out the same. All right, group of 3 here. This one's alone, this one's alone. Notice I'm only looking at my prime numbers. I'm looking for groups of 3. So I have 3 x's here, 3 y's here, 1 y left over. So let's see what comes out. I have a 2 that comes out. I have an x that comes out. I have a y that comes out. And then we have the cubed root of 3 times 2, which is 6. If it stays inside, then you multiply it together, and then a y. So that is your answer. This is what I know that you're really good at, simplifying. All right, looking for 4, groups of 4. This is 9 and 9. See how you didn't really need a calculator? And then we have 12 x's. So you can do our trick of dividing, or you can write them all out. Either way, it doesn't matter to me. And then 15 y's. That's 8. That's 12. That's 15. All right, I'm looking for groups of 4. I found a 3. I found 3 x's. And I found 3 y's. And I found 3 y's that stay in. So what comes out is 3 x's, 3 y's, and then 3 y's stay in because they're lonely. They don't have enough to go out. Okay, the other way that you could do it is just dividing. 12 divided by 4. You get 3, right? and then you can do 15 divided by 4. You get 3 with 3 left over, right? That's your answer. All right, next one. Let's see if we can simplify this first. I know that I might need to rationalize, but maybe not. This is negative 5x divided by,
We're now all clear.
there's a group of 3 and a group of x's. So listen, when you can take everything out of the radical, there's no more radical. It's gone, which is good because I didn't really want to rationalize, so we didn't have to. All right, next one is the 4th root of 32. That's 8 and 4, just still breaking it apart. Notice how they're very small numbers, right? Nothing to be intimidated by. 4 A's and 5 B's. I'm looking for groups of 4. I found a group of 4 here, 1 left over. Found a group of 4 here and a group of 4 here, 1 left over. All right, so what comes out? A 2 comes out, an A comes out, a B comes out. What stays in? A 2, no A's, and 1 B. That's it. You guys are good at that one. We've done that a lot. All right, 24. Let's do 8 and 3, 4 and 2, 2 and 2. Looking for groups of 3. Group of 3 there. That one stays. 8 A's. That's 8 and 14 B's. Holy cow. 4, 6, 7, 8, 9, 10, 11, 12, 13, 14. We're in a room. Looking for groups of 3. Group of 3, group of 3, you stay inside. Group of 3, group of 3, group of 3, group of 3, you stay inside. You can use the division rule here too. What comes out? A 2, 2 A's, 1, 2, 3, 4 groups of B's. And what stays inside? A 3, 2 A's, and 2 B's. There you have it. You can do the division too. You can say 8 divided by 3, that's 2, right? That's the number that comes out. And then there's 2 left over. That's the number that stays in. 14 divided by 3, that's 4, right? That's the number that comes out with 2 left over, and that's the number that stays in. All right, 4 more. You almost made it. Adding and subtracting, remember, index and radicand have to be the same. Index and radicand have to be the same. They are not the same. They are not like terms. So I need to simplify to see if I can make them like terms. This is 25 and 3, 5 and 5. So whatever comes out multiplies with the number outside. So we have 5 root 3x minus 15 root, that stays and that stays, 3x. 5 minus 15 is negative 10. The root 3x is the term, so that doesn't change, and that's your answer. All right, next one, same thing. You have to have like terms in order to add or subtract. These are not like terms, so I need to break it apart. Whatever comes out, you multiply it with the one out here. So this is 45 root 2, 2 and 4, 2 and 2. Multiply it with the number out here. So that's 10 root 2, 8 and 6, 4, 2, 2, 2, 2, 3. 2 groups, nice. So I take out a 4, 4 root 3. All right, so it looks like these match, but this one doesn't. So when I add or subtract, I can only put these together. So I'm just going to do 45 minus 10. I get 35. Square root of 2 plus 4 square root of 3. That's your answer. All right, last, number 28, almost there. Can't add because they're not like terms. So we're going to break this apart. 4 and 10, 2 and 2, looking for groups of 3. And this is, there we go. So groups of 3, I see 3 2's, 5 stays in, 3 x's, x stays in. So we have 6x times the cubed root of 5x plus 2 comes out, multiplies with this 2, we get 4. 1x, then we have the cubed root of 5x. They are like terms now, right? The index and the radicand are the same, so we can add our numbers in front. 6x plus 4x is 10x, and the cubed root of 5x. Nice work. All right, let's break this apart. Look, it's negative inside. So it's the cubed root. So I want to know, can I multiply 3 numbers together to get a negative number? Yes, you can. So whatever my answer is going to be, it's going to be negative. So I have 5, 25, 5, and 5. I'm looking for groups of 3. Groups of 3. 10 x's, 12 y's. You can use the division trick here too. All right, so looking for groups of 3, that one stays. Looking for groups of 3, I can group all of them. So 5 comes out, 3 x's come out, and 4 y's come out. And the cubed root of just an x inside. Notice I want to know what multiplies 3 times that's negative. This number is negative out here. So if it's an odd root, you can pull out the negative. If it's an even root, it's imaginary, right? Okay, and you can do the division rule there too. 10 divided by 3 is 3, with 1 left over, he stays inside. 12 divided by 3 is 4, all 4 come out, none inside. All right, so just go back and practice some of these if you were unsure. Another great practice would be going back and doing some of your homework questions again, and then also the quiz, looking over the quiz questions as well. Good luck. I know you're going to do great.